This video will be about configuring the dynamic routing protocols OSPF, BGP and IS-IS, and I will show you how to redistribute these protocols. So in order to do that, I have created a basic diagram, and as you can see here we have our ESG and our LDR, which were already connected with each other, and in our last movie I showed you how to make routing work with static routes. Right now I've removed the static routes, and I'm going to make it work with OSPF. So I have one Cisco device, an iOS OSPF router here. I have another Cisco device which is doing IS-IS here, and I have another Juniper IS-IS router which is sitting over here, and a BGP router which is a Cisco IOS device as well, sitting here. So the ESG will have different interfaces towards these networks where other routers are connected. Each router also has a loopback configured. So this router here has this loopback 192.168.100.1, I believe, and this one is in the 115 network, this one is in the 110 network, this one is in the 120 network. So eventually we will all have to, all these loopbacks are going to be advertised to the ESG, and the ESG will then redistribute that into OSPF, because the ESG will only talk OSPF with the LDR, and then eventually all the VXLAN networks, or the networks that are behind the LDR that are actually connected to a logical switch, will have access to all the different loopbacks. Well, you can also see a CS1 here. This is actually my physical switch, and my physical switch also has a network here. It has the 10.11.11.0 network, which is my management network, and the 10.66.66.0 network, which is an SVI, a VLAN 66 on the physical network as well. So I'll make sure that that network is also distributed through OSPF into IS-IS or BGP. So let's start. I will refer to this diagram a little bit more. I also have another diagram which basically explains the routing, where you can see my application servers, my web servers, my DB servers, which are connected to the LDR through a logical switch, and my LDR is connected to my ESG also through a logical switch, and on the ESG I have different networks or different interfaces to all these different external routers from different vendors, Cisco and Juniper, and this will go into the VDS. The VDS is connected to my physical access switch, and this is a physical core switch. This is a firewall, and this is the internet. For this part, you will see that the core switch has the 11 network and the 66 network, what I just explained. So the goal is to have dynamic routing working. So let's start with the. I'm really excited to do this video. So let's see where we're going to start. First of all, we're going to verify the NS6 edges to see if the LDR interfaces are there. And you can see my logical switch interfaces are all here, and my connection to the ESG is there as well. So let's check the ESG as well. Let's go to the interfaces. And you will see all the different interfaces here. One is going to my physical network, the other one is going to the LDR, and others are going to the external routers, iOS, SRX, VMX. So I changed this a little bit around. Let me first of all change that name. Oh, this is wrong. Let me change this name here just to make it a little bit more IOS BGP, and this one is going to * and iOS, and this one is going to do IS-IS. So this is just a name, and to make it complete, let me rename this one as well to OSPF, so we exactly know which interface is going to do what. Okay, as you can see with the routing here, everything is disabled, and I did that with hitting the reset button, and the same can also be done with the LDR. Let's go to routing, and everything should be clean. Yes, everything is clean. So let's start with configuring, let's go step by step. Let's start with configuring OSPF between the ESG and the LDR. Okay, so let's start with doing that right now. So let's start with the LDR. What we want to do first is create or assign a router ID. So let me do that. I will use, well, this interface here, the to ESG interface as the router ID. There's nothing wrong with that. So let's publish it. I will not configure a default gateway here because the routing will be fully dynamic. So I will not touch this at this moment. So let's start with enabling OSPF. So we have to go to OSPF. We need to edit the configuration. We will enable OSPF, and it will ask for a protocol address and a forwarding address. So the protocol address and the forwarding address, let me go back to my diagram here. We will see that the forwarding address has to be something, well, has to be this interface. So let me copy that. And the protocol address will be the address that it will use in order to make sure that OSPF will work. So it has to be a new IP address. And let's first configure the forwarding address, and this one I will just assign another IP address, free IP address in the pool. So at this point I will not enable a default originate right now from here, because I basically want to do the default originate from this device here, that it will be injected to this LDR, so everything behind the LDR, which will do OSPF, will know that the default gateway or default route is always here at the ESG side. So let's hit OK, and let's also create a new area 0, or maybe that was already there by default, and let's map the interfaces to the ESG here, because we want to use this interface that's going to do OSPF to the ESG. So let's hit OK, and let's publish the changes that we just created. Let's see if it gives me an error. It doesn't. So right now we have configured the OSPF interface to ESG. We're using area 0. We've configured a forwarding and a protocol address, and the router ID we've already done. So in order to, well, we can also verify right now if we connect to the ESG. Let's connect to the ESG console and log in. And if we do a show IP route right now, we cannot see the networks that are connected to the logical switches. So these networks here, the 12, 13, and 14, those are not listed here. Only the connected networks are displayed here. And if we do a show OSPF, show IP OSPF neighbor, we don't have any neighbors. So we want to neighbor with the LDR, of course. So let's go to the ESG and let's configure the ESG. So let's go to the routing settings, and first of all we need to configure a router ID. Right now I'm going to use the 2physical interface as my router ID. So let's hit OK. Let's do that again because that didn't go well, I guess. Let's hit publish changes, and the router ID is configured. So as you can see here, OSPF is still disabled. So let's do the same here. Configuration is almost the same. So we are going to edit, we are going to enable OSPF. This time we are going to enable the default originate, and let's hit OK. And we're going to map an interface towards the LDR in area 0, and let's hit publish changes. So right now the ESG is doing OSPF as well. So let's verify and do the show IP route, and we still do not see anything. So let's do the neighbor statement. So right now we are seeing that it has one neighbor. It has the 192.168.11.253 as a neighbor, and the address is 192.168.11.252. So this is the interface that we just created, or the routing interface that we just created here. So it has a neighbor. So let's do the show IP route again, and then we can see that we are receiving the 12, 13, and 14 routes through OSPF. So let's take the drawing again here. We have an OSPF neighborship here, and these networks here are actually advertised to the ESG. So now that's done, and OSPF is working between these two. I'm going to create an OSPF neighborship between this OSPF router here and my physical network here. So let's start with the iOS OSPF router first, and I need to log into it again. So we can see that if I do a show version here, this is just an iOS router, and it's a Cisco 1700, and I show IP OSPF neighbor, nothing's there, OSPF is not even configured. So I made a preparation of the configurations. So right now we are going to configure, well, the first router. We're going to add a loopback address, which I just showed you is the 192.168.100.1 network. This IP address is already configured, so I don't need to do anything with that. But yeah, let me just remove that. And we are going to create a router ID, or create an OSPF process with a router ID, and we're going to put these networks into area 0. So let's copy this and paste this off. Let's save it. So right now, what we also need to do is, on the ESG, we need to create another interface mapping, which is going to OSPF, right? So let's do that also, because otherwise we won't get any neighborship statements. And we've enabled iOS on this interface as well. That is going to the iOS router. So let's check right now if we have a neighbor, and well, we have a neighbor. So if I do a show IP route here, let's just wait for the, well, we can also verify the ESG, by the way, by doing a show OSPF neighbor here, and we see that the Cisco router has been added, And if I do a show IP route here, I believe that the network that we're looking for is the 192.168.100 should show up actually. So let's wait for the routes to converge, etc., etc. Now, in the meanwhile, I'm also going to configure this physical device here. Show IP OSPF neighbor. There's no neighbor here, so let's do that on freestyle. Router OSPF 100. Let's configure a router ID, which is going to be my local address or one of my local addresses. Let's configure a network 10.11.11.0 area 0. Let's configure the other network that I promised to do, the one in VLAN 66. Let's hit save, and what's also important to do is also configure the interface on that's going to physical. I want to use area 0. Let's hit OK, publish. So I'm doing this step by step, so you can see exactly what's happening. So if I go to the ESG again, and if I do a neighbor again, then you can see another neighbor has been added. So you can see that the state is full, DR, BDR, and if I do a show IP route, I have received the 100 here, and I also received the 11 and the 66 networks that you can see here and here. So that works. Let's do another verification on the OSPF router. I did a show IP route here, and you can see here that I received the 12, 13, and 14 networks, and the 100 well, is actually my local connected one, and what's also received is the 11 and the 66, which came from my physical device. So what we've done right now, let's go back to the diagram, is that we have enabled OSPF here, here, and here. So all of these devices here, and also here by the way, all of these devices in OSPF can see each other's network, and we've just verified that. So let's go a step further. Let's configure IS-IS right now. So we're only going to configure IS-IS on the ESG, so not on the LDR here. So let's go back and let's hit the IS-IS tab, and the IS-IS configuration is a little bit different. So right now we are going to hit edit. We are going to enable IS-IS. We need to type in a system ID. Well, the system ID that we're going to use is 1000 0001. This system ID has to be unique. Each router has its own system ID. Okay, so let's do level 1 and level 2. I don't want to configure any passwords. And let's configure the interface mapping immediately. We're going to configure an external router to the iOS and IS-IS device. So we're going to do level 1 and level 2. And let's hit OK. And also let's configure an area, because one area is mandatory. The area that we're going to use is 49.1111. This area needs to be the same for the whole complete area that we're going to configure. As we look in the drawing, we're going to configure the ESG, the Juniper IS-IS, and the iOS IS-IS device in one area, because we're going to keep it fairly simple for now. Okay, so let's hit OK for the area. And we've enabled IS-IS on the ESG. So let's go to the ESG again, and let's do a show IS-IS neighbor command. We don't see any neighbors for now. If we do a show IP route, for now we don't see any IS-IS routes as well. So the IS-IS route that should pop up is the 192.168.110 and the 115. But in order to do that, we first need to configure these IS-IS devices. So let's start with the iOS IS-IS router. The iOS IS-IS router. Let's log into that again. I'm hopping through different routers. So as you can see here, if I do a show version, this is also a Cisco 1700, and show IS-IS neighbor, there's nothing. Show IP route, there's nothing there. Yeah, well, the connected and the static route, that is already there. So let's start with configuring IS-IS. For this router, I have made a preparation as well. And what we're going to do is we're going to create a loopback 0 interface with this IP address, which is going to be advertised in IS-IS. This IP address is already configured, but we need to enable IS-IS on the interface, and then we're going to create a router IS-IS process with the net system ID that's unique. So that's a tree here. We used the 1 at the ESG, and we're going to use the metric style wide. So let's copy paste this into this router here. And right now, let's hit right, we have enabled IS-IS between the ESG and the iOS device. So if I do a show IS-IS neighbors, we can see that I have two neighbors here, one for level 1 and one for level 2, and they're up. So let's do the same for the ESG. Show IS-IS neighbors, and we have two neighbors that are up. So if we right now do a show IP route here, we can see that we have one IS-IS route here, which is the 192.168.110, which is the one that we advertised. So let's go back to the diagram. We've now enabled IS-IS between this iOS device here and the ESG. So let's do this on a total separate device, on a Juniper. And let's log into the Juniper. This is the Juniper. If I do a show version here, why? Oh, show version. Then you can see that it's a virtual router, it's a JunOS, it's the Firefly virtual machine. So let's do configure again, and right now I also prepared the piece of configuration for IS-IS for the Juniper device here. And this one is not needed right now because it's already configured. Oh well, the IP address is already configured, so I need to enable ISO on it. I will create a loopback 0 interface with that address that's going to be advertised, and you can see here that the ID here, I've used 2 here, the iOS device has 3, the ESG has 1. So the level 1 and 2 metrics are wide. And I'm going to enable IS-IS on the interfaces. This part here is needed because it's a security device and we need to enable forwarding, etc, etc. So let's copy this and paste this into the device. I won't take my exclamation marks, but that's not a problem. So right now, if I do a show the pipeline compare, you can see that it's going to add all of these commands in. Let's do a commit, and if I do a show IS-IS, no, I need to go back. Show IS-IS adjacency, command is a little bit different. Then you can see that I have an adjacency with my iOS device, and I have an adjacency with my ESG. Well, there are actually four, one for level 2 and one for level 1 routes. So let's do the same for the ESG as well. Let's see my neighbors, and we see that the 002 and the 003 are, or the systems are enabled here. Let's do a show IP route, and we can see that the 115 has been added. And let's do a show IP route as well on the Juniper device. Show IP route. Show route. And we can see that, well, the 110 is learned through IS-IS here as well. So we can do another verification at the IS-IS router here. We can do show the neighbors, and we can see that this one has been added to that, the router 4, which was the Juniper device. And let's do a show IP route. And if I'm correct, the 115 should be added here as well. Yes. So to recap, let's go back to the diagram. We can see that this device here has also joined the IS-IS process. So we have one more thing to go, or actually two, by the way, but let's first start with well, configuring BGP on the ESG first. So let's configure BGP, and BGP is here. So let's configure BGP. Edit, let's enable BGP. The local AS will be 65000, and let's hit OK. I want to have my neighbors already listed. So my neighbors will be, the IP address of my neighbor will be 10.10.108. Let me see if I have the IP address correct. 101. Let me just copy paste it from here. It'll be easier. And the remote AS, I will just configure iBGP. So we'll use the remote AS. That's going to be the same. This will be default because I don't want any complexity here at this moment. So that will be okay. Let's hit publish. So right now, let's go back to the ESG. Show IP BGP neighbors. It says that the neighbor is up. Why is the neighbor up? Let me see. It could be that I did not clean the configuration correctly. Well, let's just connect to the BGP device. Show IP BGP neighbors. Oh, it's not active. So let's make it active. With this configuration here. We don't need this because this is already configured, the interface. We are going to add in a loopback. We're going to create a BGP routing process, routing ID, which is same as the loopback, and we are going to, well, advertise the networks and create a neighborship statement, and also make a static route because BGP requires that it has to has the routes in its own table first before it actually advertises it. So let's do that. So right now I'm going to do a show IP BGP neighbors, and there you go, we will see our neighbor. And let's do a show IP route here. We're not receiving any BGP routes from the ESG, but let's go to the ESG and do a show IP route. And if we're correct, we should see a BGP route anytime. Let's just wait. Local host is correct. The remote host is correct. Well, minimum time between advertisement is 30 seconds. And keep live 60 seconds. BGP state is up at this point. And we can see the BGP route here. It's, well, with a B in front. And it's the network that we actually expect, the loopback of the BGP router. So right now we have configured BGP, let's go back to the diagram, BGP between the ESG and the iOS device. And this network is advertised. So right now we have configured dynamic routing with OSPF, with IS-IS, and with BGP. And the goal is to, well, make sure that these networks here that are behind the logical switch or are in the NS6 environment, that these networks can access the loopback interfaces of the different routers in, well, through the different protocols. So how are we going to do that? So the LDR only talks OSPF with the ESG, and the ESG is basically, well, the hub for all the different spokes. So we need to redistribute IS-IS, and we need to redistribute BGP into OSPF. But also we need to redistribute OSPF into IS-IS and into BGP, because it needs to have a route back, right? So right now let's just open one of the virtual machines that are in the application network. So that's or in the web, that's a 12. It doesn't really matter which one we take, but let's go to the application. Okay, let's open the console, and we can see here that we have a, let me see if this will work. Yeah, we can see that it has a network address in the 12 network. It's 192.168.12.101. So, for example, let's do a ping to my physical network. No, this was a wrong. Oh yeah. No, this will work. Why is this working? Because it's learned through OSPF. Okay, so that's normal. That's normal behavior. I was confused, but this is normal behavior. But let's take another network that is, for example, in IS-IS, which is the, let's take the 110. Ping -C4 192.168.110.1. I believe that was the, yeah, that was the network. So let's hit ping. It says destination is basically not reachable, or net is unreachable. So in order to make this work, we need to redistribute the protocols. So let's go to the redistribution tab, and the redistribution only needs to be done on the ESG, because this is the only part where we, well, bring IS-IS into OSPF, bring IS-IS into bring IS-IS into OSPF, bring OSPF into IS-IS, bring BGP into OSPF, and bring OSPF into BGP. For now, there's no need to bring BGP into IS-IS or IS-IS into BGP, because that's not our goal at the moment. So let's start the redistribution. Right now we want to redistribute, well, we want to enable everything for redistribution. What do we want to redistribute? So the learner protocol is OSPF, and we want to make sure that OSPF, that IS-IS and BGP is, well, advertised into OSPF. So let's hit OK. What we also want to do is we want to bring OSPF into IS-IS and bring OSPF into BGP. That makes sense, right? So let's hit publish. And right now, well, let's first not hit publish. Let's first look at one of the routers. That would be a good example. So right now we know that BGP has 192.168.120 here, and we know that we're going to advertise this network into OSPF. So eventually this iOS device here will see this network. Okay, so this is just one simple test as well. So let's go back, and if I do a show IP route again here, we cannot see the 120 network showing up in OSPF right now. So the moment that I hit publish here, let's do that. Let's go back. Let's show IP route. And we can see the 120 network here. So I've just taken one network. We see a lot more, of course, because there are a lot more there's a lot more, well, also IS-IS routes that are joining OSPF at the moment, but we will focus on the 120 here, and we see that it works, right? So let's go back to the application, the app01, and let's see if I can ping this route that is in IS-IS. If I can ping it right now, and I can. So that means that my route redistribution is actually working.